Hi everyone, welcome to lecture 31 of your electric circuit class. And lecture 31 is about maximum power transfer. And of course that is in AC circuits. The objectives of this lecture: the first objective is to know the condition for maximum power transfer. And the second objective is to compute the maximum power. So maximum average power transfer. So for maximum power transfer to a load impedance ZL, the load impedance ZL must equal the complex conjugate of the Thevenin's impedance. What that means? It means that if we have a linear circuit and it has two terminals, and then our ZL connected across the terminals, then we can find our V Thevenin and we can find our Z Thevenin. So this is the Thevenin equivalent circuit, and then that is our ZL back there. So if V Thevenin, I mean Z Thevenin, if Z Thevenin is equal to R Thevenin plus JX Thevenin, then for the load impedance ZL to receive maximum power should equal to Z Thevenin conjugate. So this over here is conjugate which means since our Z Thevenin came out to be R Thevenin plus JX Thevenin, So our ZL, since it has to be Z Thevenin conjugate, then that will be R Thevenin minus JX Thevenin. So for maximum power, ZL should equal to Z Thevenin conjugate. This is the condition. Why is that? Because as you know, our circuit, for example, if I have a circuit like this, and this is, let's say, 120 with angle 0, and then over here we have, let's say, 4 plus J6, then our ZL over here to receive maximum power should equal to 4 plus J6 conjugate, which means that will be 4 minus J6. So if you look at this, our Z Thevenin here is 4 plus J6. Our Z load to receive maximum power is 4 minus J6. So this is a single loop circuit over here. So when we are saying that 4 plus J6 plus 4 minus J6, then if you look at that, this J6 and minus J6, they will disappear or cancel each other. Then we will have what? Pure resistive load. That is why it has to be the conjugate, so the imaginary part will cancel out. So the value of maximum power is P max is equal to V Thevenin squared divided by 8 R Thevenin, and that is in watts. So this is the formula for maximum power in AC circuits. So however, I would like you to note the following. If RMS voltage value is used, then our Pmax will be the same as the formula for DC. So that is V Thevenin RMS squared divided by 4 R Thevenin. Don't forget that. So if we are using VM, then this is our formula, V Thevenin squared over 8 R Thevenin. If we are using VRMS, then this is our formula over here. So let's go over an example here. So find the value of the load impedance for maximum average power. And this is our circuit here. That is a 12 with angle 0 volts. This is negative J4 ohm. $15 ohm, 20 ohm, 4 with angle 0 ampere, and this is our ZL. So we have to pay attention to what the question is asking us. So if you look at the question here, it's saying that find the value of the load impedance for maximum power average, for maximum average power. So over here, if you look, the question is asking only about the value of ZL. So we do not need to find the value of the maximum power. So to do that, we have to calculate Z Thevenin, because ZL is equal to Z Thevenin conjugate. So the first step is to find Z Thevenin. So now Z Thevenin over here, we look at the circuit. The circuit, it has only independent sources, no dependent sources in the circuit. Then that means we can go with the reduction method. So our circuit here, it will be like this. The voltage source will be shorted. Then we have negative J4. We have 15. We have 20. The current source here will be open. And then this is where we open ZL, so we need Z Thevenin here. So if you look at the Z Thevenin, negative J4 parallel with 15, and then plus 20. And that is equal to negative J4 times 15 over 15 minus J4 plus 20. And that is equal to 21 minus J, 3.73 ohm. So this is our what? Our Z Thevenin. So ZL for maximum power should equal to Z Thevenin conjugate, and that means 21 plus J, 3.73 ohm. So to conjugate, you will just flip the sign of the imaginary part. If we have, let's say, an impedance came out to be, let's say, 50 with angle 30 degrees, then this over here conjugate, it will be 50 with angle negative 30. So we flip the sign of the angle, while over here we flip the sign of the imaginary part. So let us go with another example here. Determine the maximum power transferred to ZL in the circuit. And our circuit look like this. This is our ZL, J8 ohm, 6 ohm, 2 with angle 0 ampere, RMS, six ohm, 7 ohm, 2 IX, and this is where IX is flowing. So in this case, if you look at that, we do have the independent source over here is given in RMS. So we have to pay attention for the final formula for our maximum power. So solution over here, if you look at that, we need to open the ZL. So that is the first step. So our circuit will look like this. that is 6 ohm, J8, this is 6 ohm, this is 2 with angle 0, and that is ampere RMS. This is where we open our ZL. To IX, and our IX is flowing here. So this is where we need to find VThevenin. So the solution here, since there is a dependent source plus independent, find VThevenin, I short circuit, then our ZThevenin is equal to VThevenin over I short circuit, right? We have done that before. So if that is VThevenin and this is, let's say, our ground, then this over here we can call it VThevenin, this node. So now we can say VThevenin, or at VThevenin at that node. So we can say VThevenin minus 2IX divided by 6 plus 7, that is 13 ohm. So we found the current flow in here. Now the current flow in here, that is 2 with angle 0 plus 2 with angle 0, and that is equal to 0. So if I multiply by 13, we are gonna get VThevenin minus 2IX plus 26 with angle 0 is equal to 0, which means that VThevenin minus 2IX is equal to negative 26 with angle 0. And this is our first equation. So now we have one equation, but we have two unknowns. So we have to come up with our controlling variable equation, which is Ix. And Ix in this case, if you look at it, this is Ix, and the current flow in here is 2 ampere, and that is in the opposite direction, so that will be negative 2 with angle 0. And this is our second equation. Please pay attention. When we have, for example, Ix is equal negative 2 with angle 0, this is equivalent to 2 with angle 180 degrees. The reason behind that, if I have, for example, over here 2 with angle 0, the negative 2 is here. That is negative 2 with angle, let's say 0, which is the negative. So now we went from this point to that point with 180 degrees, or we can go from this point to that point with angle negative 180. So negative 2 with angle 0 is equal to 2 with angle 180, and at the same time is equal to 2 with angle negative 180. All of those are equivalent, so they are equivalent. So now we go back to our problem here. So if we substitute equation 2 into equation 1, we are going to get our VThevenin is equal to negative 2 times negative 2, which is equal to negative 26 with angle 0. I mean what I meant is the following, that when we substitute equation 2 into equation 1, then we will have V Thevenin minus 2 times negative 2 is equal to negative 26 with angle 0. So from that, our V Thevenin is equal to negative 30 with angle 0, and that is equal to 30 with angle 180 degrees, and that is volt RMS. So now the second step, we need to find I short circuit. So this is our circuit here. This is 6, J8, 6, this is 7, this is our voltage source, which is 2IX. This is where IX is flowing, and this was our terminal, right, where we open it, where ZL is open, so we will short it, and we need to find I short circuit. And there is our current over here, which is 2 with angle 0 ampere RMS. So this is what we need. We need I short circuit. So in this case, we can go with this as I1, and this over here, let's say I2. So loop 1, that is I1 is equal negative 2 with angle 0 ampere, and this is our first equation. And then loop 2, we can write 6I2 plus 7I2 plus 2IX is equal to 0, which means that 13I2 plus 2IX is equal to 0, and this is our second equation. However, now we have two equations with 3 unknowns. Then we need the equation from the controlling variable Ix, and our Ix in this case is equal negative 2 with angle 0, and that is our third equation. So now if we substitute 3 into 2, this is what we are gonna get. Or you can put that in, let's say, matrix form. That is okay too. So substitute equation 3 into equation 2. Then we will get 13I2 plus 2 times negative 2 with angle 0, and that is equal to 0. So from that, we can get our I2 to be 4 with angle 0 divided by 13. Because as you can see from here, we can say 13I2 is equal to 4 with angle 0. And then our I2 is 0.308 with angle 0 ampere. So now I2 is known, this I2 is known, and I1 is known, because I1 we said that is negative 2 with angle 0. So our I short circuit based on this circuit, that is I1 minus I2. I1 is negative 2 with angle 0 minus I2 is 0.308 with angle 0. And the answer here is negative 2.308 with angle 0. However, that is equivalent to 2.308 with angle 180 degrees ampere RMS. So our Z Thevenin is equal to V Thevenin divided by I short circuit. And V Thevenin came out to be 30 with angle 180. And our I short circuit came to be 2.308 with angle 180. And the answer here is 13 ohm. That is our Z Thevenin, which means that our ZL is equal to Z Thevenin conjugate, which is equal to 13 ohm. So there is no imaginary part here. So 13 ohm. So our Pmax is equal to what? Is equal to, our values are in RMS. Don't forget that. So V Thevenin RMS squared divided by 4 R Thevenin. And that is equal to 30 squared divided by 4 times 13. And the answer here is 17.31 watts. 17.31 watts. By this, we are done for the maximum power topic. So I would like you to pay attention to the following. First of all, that for maximum power, our ZL should equal to Z Thevenin conjugate. The second thing, our Pmax is equal to V Thevenin squared divided by 8 R Thevenin, or Pmax is equal to V Thevenin. If that is given in RMS squared, you will need to divide by 4 R Thevenin. If you know all of these, then you will be good in good shape for this lecture. And this is our homework for this lecture. Thank you for watching.